everyone. Thank you for joining to for my final events of Master's Score. I'm Level Duong from Computing Architecture-Le, and today I would like to present about my thesis defense with the title is MRSA a high efficiency multi-row mixed switch accelerator for cryptocurrency mining and data security. Uh, First of all, I just introduce about the blockchain technology. Is a famous technology that's used in most cryptocurrency systems today, such as Bitcoin and Litecoin. Bitcoin brings many benefits to our life, such as the transparency, flexible distributed architecture, open source automated operations, worldwide adoption, security, high efficiency, faster transaction, and also reduce transaction cost. In, in blockchain, the data are stored in the chain blocks, and many data include the transaction data are stored in block. And when the new block are added to the blockchain, it requires we need to have to find the proof for adding the new block, and most the way to find a new block called the consensus mechanism. And proof of work with the mining process is the most popular consensus mechanism today. About proof of work consensus mechanism, um, the table on the left side, so the block header structure, it includes 6 fields. It is the input for the mining process. When the miners would like to begin their mining process, he have to take some spending transaction in the main pool memory and make the candidate block. And he have to find the local root field, and the 6 field of the block header also have to be found in there. And these fields are show the difficulty for the mining process, and the nodes are the value the miner have to find for accepted in the blockchain. And then the miner have to take the input and using their mining processor to calculate the hash output. They have compared with the target, and the target are calculated from the NBIS field. If the hash output are lower than the target value, the nonce value are accepted and the new block are added to the blockchain permanently. If not, they have to increase the nonce value and recalculate until finding the valid hash. The mining process until now is spending much computational power to get and maybe larger than the reward value for ensuring the security. And in this research, we are implementing about research about the Scrypt algorithm. And Scrypt algorithm is one of the most ASIC resistant mining algorithm. In this Scrypt algorithm, we have the parameterizable. In this case, the miner can control how much memory are used in the algorithm and how many loops in the main step in the algorithm. And the Scrypt includes 3 main steps. The first and the third step are BDK2 function, and the second step are Romix function. With the BDK2 function, it includes many SHA-2 calculations, so it have a very high dependency between loops. And the Romix function includes 1024 loops of writing and reading to a large memory, so it also have the high dependency and memory intensive. So on many when performed in many general hardware, it still have a very low performance and efficiency. So the problem in the traditional mining process are using the Bitcoin blockchain use the double SHA-256, so it can be easily dominated by A6 miners. For example, on the right side is the Bitcoin energy consumption when compared to select country. The total energy consumption is 120 terawatt hour, so it's high computation. And with the Scrypt algorithm, we have three main characteristics can avoid the advantages bring from the A6 miner. So because when the and mainly focus on the parameterizable, because when we change the parameterizable, the A6 can be easily be useless because it cannot work properly. On general hardware, it's still low performance and efficiency because it's have a very high efficiency. It have a very high dependency between loops. But on the FPGA, with the flexible energy efficient for support the pipeline processing, so it is suitable for developing the Scrypt hardware with lower cost for mining system. And this is the first step to creating the new efficient hardware architecture generation. And in this research, we would like to increase the hardware efficiency. In that we can increase the mining benefits, and also we could avoiding the current A6 with low efficiency and domination that bring to the risk for the blockchain. And also we can set the environment to avoid these mining farms like this. And this is the overall comparison between our proposal with other hardware platform. In this, although the speed is lower than ASIC, but most other criteria can be achieved excellent level. And the speed are not important to reach the highest, because when the difficulty increase higher, so everything will be dominated by ASIC miner. So we would like to balance the performance between the blockchain environment. These are some related work for in the blockchain mining, and in that we can say they only focus on the traditional mining algorithm, that is double SHA-256 for Bitcoin mining, and although they also improve the performance, but they cannot eliminate the ASIC miner advantages because of outstanding performance for achieving higher benefit. And about Scrypt related work, this is my previous work for Scrypt core with the Duong pipeline. But although it's only increased performance for previous work, but when compared with the general hardware such as CPU, A6, and GPU, it cannot outperform. About the proposal, is the first proposal called configurable architecture with the runtime configuration parameter to reduce the configuration time on the FPGA and increase the flexibility for applications. This is the table show the memory map for the configurable architecture, and most of the configurable register we have to the control register is to show the status of the status register to show the status for the hardware, and the control register to configure the mod for the hardware, so that user can easily configure the mining system when the blockchain change the mining rules. Also, with the mod bits, we can control if the hardware are using in mining for mining system or general application. With mining system, we can auto update nodes to reduce the transmission data. With the second proposal is the multi-roaming Scrypt core. In this proposal, we use the pipeline architecture. That's the roaming. We see that the roaming take the highest number of cycles for 98%. So we can increase hashing performance 66 times to when apply this architecture, that is the cyclic Romex B array, that we only use one BBKDF2 for the first and the third step, but in the middle step, the Romex BE are duplicated into 64 processing elements. And this is the timeline for the architecture. You can see after 66 cycle, the per input come, and then after each cycle, we have one input for each cycle. In Graph, we can increase the efficiency significantly because we only use one V1 and one V2 core. We could reduce the number of V1 and V2 core, but we will also increase the performance efficiently. And the last proposal is the rest rescheduling technique. In this proposal, I focus on the inside the Romex BE, and inside the largest module is block mix core, and the block mix core have two main module is column round and round round. Each have the same function but different order. When reduce the one round module for each Romex core inside, you can see I can reduce approximately 40% resource of each Romex BE. So about the research method, I are divided into five steps. First of all, I get the test data from cryptocurrency network through MATLAB software, and then I implemented the Scrypt programs on C++ for CPU and CUDA program for GPUs. And I also designed the mining hardware on the FPGA and optimization with a very low cost. And finally, I evaluate on to compare the efficiency between hardware and software through C++ and very low. If verification on real hardware, I have taken the input data set. It is a 1 million block header from many blockchain from Litecoin, Filecoin, Dogecoin, Megacoin blockchain. And the system operating supply for 3 IPs is on the 1 megahertz. This is the SOC system. And about the result, implementation result, this is my implementation result on CPU and GPU. On CPU, the maximum power can reach 120 watts, and on GPU, it reaches up to 330 watts. But the hash rate on CPU is the maximum at 1080 kilo 800 kilohertz, and on the GPU it can reach 80,000 kilohertz per second. When compared to my proposal with the FPGA, on the FPGA Unveil U280 is improve the energy efficiency for 24 times to 52 times. It is the hash per joule. Yes, the number of hash per joule is the energy efficiency. When compared with the CPU, it can improve the efficiency from more than 800 until more than 1,000 times. When compared with the FPGA works, I implement many versions of number of processing elements. The maximum option is 64 processing elements. I compare with the conventional version, just one processing element. On the Unveil FPGA, we can improve the energy efficiency for more than 65 times. When compared on the Vertex 7 with the research, my previous research, it can improve more than 6 times in energy efficiency. But when compared with the MRSA1 Rubik's PE, it improves more than 2 times. On the detect inject scale, it can also improve the energy efficiency more than approximately 4 times. And it's multiple quantitative evaluation on the FPGA. We compare the difference between the number of processing elements we compare between the result. A is hardware resource, B is the power and hash rate, and the last one is energy efficiency. As we can see, the MRSA can be applied for many FPGAs depending on their research. For example, the maximum version on Vertex 7 is just for 32 the Rubik's PE, but on iPad we can implement the 64 Rubik's PE. But the maximum efficiency can be achieved on the MRSA 64 Rubik's PE version. The lower versions have the lower efficiency because there is high static power on the devices. That's one. Right. About conclusions is, in this research we have improved power efficiency significantly by 24 to 52 times compared to CPUs, and by more than 800 to 1000 times compared to CPUs. I've solved almost of typical problems and risks posed by Scrypt on ASICs, where the big byte increase the flexibility. And the future research maybe I optimize the memory usage for cheaper and smaller FPGA, because until now many medium FPGA cannot implement the 64 Rubik's PE version. Right. And this is publication for this research is on been published on the RGB Access, and there's some related research that's on my research.
Thank you for your presentation. My impression is the performance is outperformed. So is it true?
Yes, because in you can see this outperform because I have implemented it by not when compared with the commercial software, they have optimized everything, but I just implement the basic function for comparing between general hardware such as CPU and GPU I design by my own, and also the hardware. But when compared with the commercial miner, they have optimized everything in code, so maybe it's not outperform like this.
Okay, thank you. So a key idea, a main idea of your proposal is the parallel processing.
Yes.
For the hash calculation, right? So my question is, how much degree of parallelism can be achieved? So how many parallel processing?
The maximum parallel processing can be achieved is 64, because the number of cycles taking in the one processing element is approximately 64 times for when compared with the B1.
Okay, so,
yes.
So realizing the 64 parallel processing, are there any overhead or some weak points arising? No.
Sorry, could you explain?
In general, parallel processing having some overhead or such, for instance, initial processing it sometimes take much time. And I wonder, are there any overhead or problems arising you introducing this parallel processing? No.
Yes. I implement parallel processing for Romance B
Yeah.
because it takes a very long time when we have to wait when it beginning to finish the one.
Oh, so you mean no mobile,
Right.
no mobile, no input.
After you can see on the time scale, on the time schedule, you can see when the robot B0 finish its work, just uh, the uh, the next input can just transmit for robot B0 to continue the work. So the efficiency for the robot or the robot BE and E1 B2 core can reach 100% because no module are busy are idle in the working time.
Synchronization of parallel processing results becomes difficult or having no problem.
Yes, has no problem for also in transmission because you can see the number of cycle for one one is 973 cycles. So when we receive the new input, we can completely take the input completely from the software on time, not influence to this architecture.
Okay, so your proposal is completely perfect. And only the problem or the future work is including some usage of memory. You mentioned in the last slide.
Yeah, because as you can see on many lower FPGA, we cannot implement the 64 processing elements version. So we have to implement the lower such as 32 Robust PE. That is the problem is inside each Robust PE we use 128 kilobytes memory. So the FPGA, the medium FPGA do not have enough resources for implement the large version.
Okay, so my last question is very short one. Please show the number 4. That's file number 4.
Number 4.
Yes.
Number 4.
Yes. So here you mentioned the problems of the hash calculation algorithm over the hardware, and how do you find this problem? This finding is your original, right?
Yeah, because ASIC resistant algorithm is one famous criteria that the same characteristics for ASIC resistant algorithm, and Scrypt is memory intensive algorithm that can and memory intensive is not good for current ASIC architecture. That I have read some paper for they have present about this problem. And Scrypt is one kind of ASIC resistant algorithm. Yes.
You mean you found this problem through the survey the paper?
Yes, survey paper is one is on transactions on circuits and design journal. That's my yes.
Thank you very much.
I just have one comment. So I think in the next video, and the overall evaluation of the street hardware in the show.
Overall.
Yeah, I think that's it. Yeah. So, firstly, I think users noted For example, what's mean for the circle and the triangle? I think yes, people can guess, but actually you should make a note.
Oh, okay.
Yeah, and as it concerns why the speech, the CPU and GPU is circle, very good, but the A6 is not good like GPU and CPU. Do you have some mistake? And I see this table and the table in your thesis is different. In your thesis, you also use the star. So I wonder what is mean for the star in your thesis.
So this, or in the thesis, I use 5 level
Yeah.
for when evaluate the overall, but in this case, I just use 4 level.
Yeah.
The lowest zero is x symbol and go to the triangle, yes, and go to the round and the
Yeah,
one
no.
is excellent. And in the A6, although the speed are excellent, but in the flexibility, it until now it have no flexibility. And with the blockchain system are using ASIC resistant algorithm such as Scrypt, they can change the parameter, and the current ASIC hardware can work uh, can cannot work properly because it can be useless when the system change the requirement in function. So the ASIC, all the ASIC can be useless. So maybe when compared with the other two, the other GPU and FPGA.
Yeah. But why the speed of the GPU and CPU is better than the speed of the FPGA? You need speed.
GPU and CPU, GPU and CPU until now maybe outperform with current FPGA because maybe current research on FPGAs for ASIC resistant still very maybe just a few implement for FPGA. Most of them use CPU and GPU. Yeah, as for outperform in speed, but the problem is the power is quite high for ASIC resistant algorithm. But so one of is my is research is also for FPGA is the first step. Maybe the improvement for the next architecture of ASIC miner for higher efficiency. But on CPU, but on current FPGA, I just survey for previous work research. Yeah, it's still rich very low speed and maybe low flexibility. That means when you the parameter change, you can change the design and reconfigure to the new block to the device when you change the algorithm. But it is still very low and interrupt to the mining process. So we create the configurable architecture to solve to increase the flexibility. The user just can configure from the software, not have to reload the device again. I think that's
Okay. Thank you. So anyways, just make a note, and I think that sometimes people the circle and triangle. Yeah, I think you should check it more. Yeah, so content is really important. Yeah. Okay, and post the note, the meaning of the symbol. Thank you.
We are almost out of time for presentation.